In this lecture, we're going to talk about the path of the sun as seen from somebody on the Earth, mainly in the northern hemisphere, but we'll also talk about the path of the sun as seen in a few other places located on the surface of the Earth. Let me show you a simulation. This comes from the University of Nebraska simulations. We have a celestial sphere with a person marked out in a horizon diagram. I can rotate this celestial sphere around, north, south, east, and west. The blue line is the axis of the Earth. So there's the north celestial pole that I'm pointing at right now. The south celestial pole is also here. And the red lines mark out the summer solstice, equinox, and winter solstice paths for the sun on the celestial sphere. So for this person, who I've marked at 41 degrees north, which is the same latitude as our school, this person has the summer solstice path just as I described before, rising somewhere in the northeast, getting high in the southern sky, and then setting in the northwest. The equinox path rises directly east, gets high in the southern sky, sets directly west, and the winter solstice path rises south of east, gets highest on that day just above south, and then sets somewhere on the southwestern horizon. But what about for somebody else on the Earth? Well, let me go to the opposite. Let's go to 41 degrees south. This is a person in the southern hemisphere. Notice how for this person, the northern celestial pole is no longer in their sky, but the south celestial pole is. And that the paths of the sun for a person on this day will take them to the opposite part of the sky. Instead of getting to its highest point above the southern horizon, for a person south of the equator, the sun will get to its highest point in the northern sky, above the northern horizon. The sun will still rise north of east and set south of west, but it will get to its highest point above the northern horizon. And so for this person, the equinoxes still rise directly in the east, set directly in the west, but on this day, on these days, on the equinoxes, the sun would get to its highest point in the north. That's very peculiar for somebody who lives in the northern hemisphere. You might not expect that. What about for somebody who lives at the equator? Well, in this case, if you live at the equator, and I'll try to get as close to zero as possible, for somebody who lives at the equator, it is possible for the sun to get directly overhead, and that occurs on either of the equinoxes. But the summer solstice still rises north of east and sets north of west, and the winter solstice still rises on the winter solstice, the sun will still rise south of east and then set south of west. On either of those days, the sun will not get directly overhead. Remember, for somebody at the equator, that only occurs on one of the equinoxes. If you live somewhere between the equator and one of the tropic lines on the globe, so all the way up to 23 degrees north or 23 degrees south latitude, then somewhere and at some time during the year, you would be able to get the sun directly overhead. When does that happen? Well, it sort of depends on what day of the year. So for a person, say at 17 degrees north, you may have to wait for a particular day of the year that's sometime between the equinox and the summer solstice for the sun to have a path that takes it to the zenith. But if you are north of 23 degrees, let's say 30 degrees north, then no path will get to zenith, although the summer solstice path will get very close to it. Okay, so that's what it's like for people on different locations on the Earth and what the paths of the sun is like.
North Pole. A twilight period of about 2 weeks occurs before sunrise. Sunrise is just before the March equinox, around 20th March. When the sun is visible in the polar sky, it appears to move in a horizontal circle above the horizon. This circle gradually rises from near the horizon to its maximum elevation above the horizon at summer solstice. The sun then takes 3 months to reach its highest point at the summer solstice, around 21 June. The North Pole is facing towards the sun to its maximum extent, after which time it begins to sink. Once again, sun reaches the horizon, moving in a horizontal circle. Sun sets just after the September equinox, around 23 September, and continuously below the horizon during the winter. Again, a twilight period of about 2 weeks occurs after sunset. Twilight period is followed by night for almost 6 months.